Hi everyone, this is Cameron again for the sedimentary rock portion of our rock videos in preparation for the lab exam for Geology 1, Mr. Poole. So we'll go ahead, jump right in. We see this rock here. If we look very closely, you should be able to see small circular fragments, okay? You should be able to see a lot of small circles in there if you look closely. So keeping that in mind, this is a chemical sedimentary rock. It reacts with acid, and its environment of deposition, or the environment where it forms, is a warm, shallow, highly agitated tropical marine environment. And like I said, we want to look for those small rounded spheres. That's going to be the key, and one of the keys in identifying this particular rock. Okay, so that would be oolitic limestone. Okay, next up, we have this rock right here. Okay, so this one, if we look closely, we can see there's a lot of shell fragments in this one, okay? It's composed of a lot of broken shells. Okay, so it's a chemical sedimentary rock. It will react with acid, and it forms in a high energy surf zone. Okay, and so we want to keep those shell fragments in mind when we're trying to identify this rock. So that one would be coquina. Okay, the dead giveaway there is the shell fragments. That's the key in identifying that one. Okay, next up, we have this rock. Okay, this one is a chemical sedimentary rock. It will react with acid, and it forms in quiet, warm, shallow tropical marine environments. It's microcrystalline, and we sometimes can see conchoidal fracture. This particular sample doesn't have a good example, but if you look at the igneous portion, you should be able to see what conchoidal fracture looks like. Okay, so this one is actually going to be micrite, and it's sometimes easy to confuse it with chert, but the key here is that micrite will react with acid and chert will not. Okay, so that one is micrite. Put that right there. Okay, next up we have this rock. Okay, so this particular rock here, it is a detrital sedimentary rock. Okay, it forms in floodplains, deep marine environments, lakes, swamps, and lagoons. It's made up of mud-sized particles. Okay, sometimes it'll have a slightly gritty feel. You might feel some of those small mud-sized particles coming off on your fingers. And this one would be mudstone. Okay, so the key there is that it's mud-sized particles, hence the name mudstone. All right, next up we have this rock. Okay, this one is another detrital sedimentary rock, which means, by the way, that it's formed up of detritus or clasts or sediments, all right, pieces of weathered and eroded rock. Okay, so it's a detrital sedimentary rock, and it forms in beaches and dunes. Okay, and the particles here are going to be sand-sized. Okay, so this one is going to be sandstone. Next up, we have this rock. And this one's another detrital sedimentary rock. Okay, with the detrital rocks, you can usually see some sort of detritus all lithified together. Okay, it's been compacted, cementated, and we have all the particles glued together. Okay, so this one we see form in rivers and some beaches. Okay, the rounded particles here indicate that the particles have been transported. Okay. So gravel-sized rounded fragments are indicative of conglomerate. Okay, so this rock here is conglomerate. Now the next one up can sometimes confuse students. We see it looks similar. We have a lot of fragments in there. Okay, it's another detrital sedimentary rock, but this time we see these fragments indicate short transport, and we see it form in cave collapses or sometimes landslides. So here we have gravel-sized angular fragments, and so this one's actually breccia. The key difference between breccia and conglomerate is that the fragments in breccia are angular versus rounded in conglomerate. Okay, so again, that's breccia. Next up, this one here, should be able to see right away. We've got quite a bit of fossils in here. See those shells, which would indicate fossils. Okay, so this one is a chemical sedimentary rock. It reacts with acid, and it forms in warm, shallow, tropical marine environments. And the key identifying feature here is that it contains fossils. So this one is fossiliferous limestone. All right, next up we have this guy here. You can't see in the video, but if you hold this rock, it feels very light. Okay, it almost weighs nothing, honestly. It's a chemical sedimentary rock. It does not react with acid, and it forms along continental shelf. Okay, it's got a very low density, like I mentioned before, and it feels powdery. You can see all this powder coming off on my fingers here. Okay, so this one is actually diatomite. Okay. Some people will confuse diatomite and chalk, but just remember that diatomite does not react with acid. Okay, so here is our diatomite. All right, so here, you can see right off the bat, this is a very dark colored rock. This one's chemical sedimentary rock. It does not react with acid though, okay? Its main environment of deposition would be swamps, and it's dark and has a low density, okay? It looks like it should be very heavy, but it's actually relatively light. Not quite as light as diatomite, but still relatively light. So this rock here would be our bituminous coal. Okay, so once again, bituminous coal. Next up, we have this rock here. This would be another chemical sedimentary rock. This one will react with acid, and we see it form in caves and hot springs. Now the key feature here is that we see these bands, okay? It's a banded rock. You can see all those layers there. So this rock is actually travertine. Okay, so the banded rock there is our key in identifying that that's travertine. Okay, next up we have a very light rock. It's powdery, okay? And this one actually will react with acid. We also see it form along the continental shelf, and like I said, it's powdery, and this one is composed mostly of coccoliths. Okay, so this one's chalk, and again, some students have some trouble distinguishing it between diatomite, or distinguishing it from diatomite. But this one's chalk, and it will react with acid. That's the key. Chalk reacts with acid, diatomite does not. Okay, so once again, that one is our chalk. Okay, last we have this rock right here. It's another chemical sedimentary rock, and it does not react with acid. We see it form in deep marine environments or sometimes hot springs, and it's got a hard feel to it. It's very hard, and we see conchoidal fracture sometimes. Okay, so this one, I'm not really seeing a good conchoidal fracture. Well, actually, right there, we can kind of see if this comes into focus. Let's see here. Yeah, there we go. So you can kind of see our conchoidal fracture along here. Okay, so this one is chert, and again, some students have problem identifying chert and micrite. So they both have conchoidal fracture, they both feel very hard, but chert will not react with acid, and micrite will. All right. Thanks for watching.